Hi students, welcome to all of you to this concepts and snippets session. Today we are going to discuss electrochemistry, a branch of chemistry having the maximum application in our life. As you know, we are all using a lot of electronic equipments which need electrical energy. Now, the device for converting chemical energy into electrical energy as a result of spontaneous redox reaction is called a galvanic cell or also called voltaic cell. Okay, I repeat, a galvanic cell is a device for converting chemical energy into electrical energy as a result of spontaneous redox reaction. Now let us see a typical galvanic cell, that is Daniell cell. A Daniell cell is a typical galvanic cell I have shown. It consists of a zinc rod dipped in 1 molar zinc sulfate solution as the anodic compartment. You know, a galvanic cell consists of two half cells. One is the anodic half cell and other is the cathodic half cell. At anodic half cell, oxidation takes place and electrons are continuously released and the electrons flow from anode to cathode. Remember, see, the flow of electron is from anode to cathode, while the flow of current is from cathode to anode. Number 1. So, a galvanic cell is a device for converting chemical energy of reactants into electrical energy as a result of spontaneous redox reaction. A galvanic cell consists of two half cells. One is the anodic half cell where oxidation takes place and the cathodic half cell where reduction takes place. The most important thing is the anodic half cell and cathodic half cell never come in direct contact. The contact is made through an arrangement called salt bridge. It is an inverted U-shaped glass tube which is filled with a paste of saturated potassium chloride in a agar-agar gel medium. Okay. Now, a galvanic cell is represented by IUPAC rule. The anode is represented as metal bar metal ion. Okay. This is the anodic half cell. It is always kept at left. The cathodic half cell is represented as metal ion bar metal, that is the cathodic half cell arrangement. And as I told, the two solutions are internally connected through a salt bridge that is represented by a double vertical line. Thus, Daniell cell is represented as you see, zinc in contact with 1 molar zinc sulfate solution is the anodic compartment, while a copper rod dipped in copper sulfate solution of 1 molar concentration is the cathodic compartment, and they are connected through a salt bridge. Okay. Remember, the polarity of anode is negative, very important. The galvanic cell anode is negative while cathode is positive. The direction of flow of electron is from anode to cathode. The conventional flow of current is from cathode to anode. It is a spontaneous redox reaction. Now, how will you find out the electromotive force or the EMF? It is the potential difference between the cathode and the anode. Okay. So, it is the potential difference between the cathode and anode. There is a spontaneous flow of electric current. Like heat flows from hot end to cold end. Water flows from high altitude to lower altitude because of pressure difference. Heat flows from hot end to cold end because of temperature difference. Similarly, for electric current to flow, there must be a potential difference. The potential difference between cathode and anode of a galvanic cell is called EMF. Okay. Now let us do a simple problem. How to calculate the standard EMF of Daniell cell? Standard EMF means what? The conditions are standard. E0 is called the standard EMF of cell, it is measured at 298 Kelvin temperature using 1 molar solution. And if any gases are involved, the pressure is maintained at 1 bar. Pressure is 1 bar. Okay. Now let us do this problem. Calculate the standard EMF of the Daniell cell. You are given the standard electrode potential. You know the formula to calculate standard EMF of any galvanic cell is what? E0 cathode, electrode potential of cathode minus electrode potential of anode. So, always remember the potential of the cathode should be high and that of anode should be low. Then only E0 is positive, then only the redox reaction is spontaneous, or E0 cell should be positive. So, E0 copper cathode is plus 0.34, anode zinc is minus 0.76. So, you see, E0 cell of Daniell cell is 1.10. It is positive. The positive E0 cell value indicate, okay, the cell reaction is spontaneous. Or the galvanic cell will work spontaneously. Okay. I hope you understood. Yes, we'll be doing a different varieties of problems in our next sessions. Thank you.